Hello chemistry students. In this video I'm going to show you how to do density calculations, and more importantly how to do numeric problem solving using what I call the UKPS method. So we'll start off with this. Density is the ratio of mass to volume of a substance. It's usually going to be in grams per cubic centimeter or grams per milliliter, but there are certainly other units, and when we do dimensional analysis we'll talk about converting those units. But essentially the equation for density is simply that density equals mass divided by volume. And since this is an equation, algebraically, if you know two of the variables, you can solve for the third. So we'll start off talking about solving for density with mass and volume, but then also we'll talk about solving for mass if you know density and volume, or solving for volume if you know density and mass. Alright, so I'll start off with this. Kind of the origin of density is from a comparison of mass to volume. There is a linear relationship between mass and volume, and if you graph that relationship with mass on the y-axis and volume on the x-axis, then mass grows as volume does, and the slope of the line would be the change in the mass divided by the change in the volume, which would give you grams, or mass divided by milliliters, or volume. And that means that the slope of the line, the m, is the value of the density. Now, if you look at the reference table, you'll see the density of aluminum is like 2.7. It's not 2.8. So this is like experimental data. You could do a lab and measure different sized pieces of aluminum, and you would get close. And this is probably reasonable data here. All right, so let's talk about ways you could measure density, say, of a liquid. So the liquid, you would just need to know the exact volume and the exact mass, so you could divide those things. So you can read the volume of the liquid with your eye in a graduated cylinder perhaps, and then you could weigh that liquid and simply do mass divided by volume, and that would give you the density of the liquid. By the way, the density of water is about 1 gram per milliliter. Alright, so when we need to measure the volume of solids, if it's a regular solid, then it's easy enough because you can do one of the volume equations, like maybe length times width times height for a rectangular solid. But if you have an irregular solid, like it's just some clumps of lead or something, it'll be difficult for you to measure the exact volume of that. So what we do with a solid that's more dense than water is you can just drop it into a graduated cylinder that has some water in it. So you can see that this graduated cylinder starts off at a volume of 15 milliliters of water inside of it, and then when the compound is dropped in it, or the metal, it might not be a compound, when it's dropped in, the volume of the water reading in the graduated cylinder increases to 32.2. Now, what that means is that the stuff that we dropped in must account for the difference, and so what we can do here is subtract those two values to determine that the volume of the compound is 17.2 milliliters. You can measure the mass, on a balance, and then you would have the grams and the milliliters, and take the grams from the balance and divide it by the milliliters of the substance, and that will give you the density. Alright, so let's go through and talk about using the UKPS method. So the U stands for unknown, that's the thing you're solving for. K stands for known, that's the stuff that you know. So you may know more than one thing, like you need to know at least two variables to be able to solve for density, or use the density equation to solve for one of the other variables. P is the plan. In this case, it's going to be the equation that you use In other cases, it may be a list of steps that you're going to take to solve the problem. And S is the part where you actually write out and do all the solving. Now, a lot of you maybe would rather just write out the solving thing, but I find it incredibly helpful to know what your assumptions are and what your plan is when I'm evaluating the quality of your work, and also trying to give you feedback to help you understand what you did wrong. So if you want full credit for your work, please make sure you're showing all of the steps. All right, so let's look at our first practice problem here. This is density practice problem 1. So an aluminum bar with a volume of 35 centimeters cubed has a mass of 94.5 grams. What is the density of the aluminum based on this information? So the unknown here is the density of the aluminum. That's what we were asked to solve for. The mass and the volume are given, so we'll list those out and also their units. Our plan, we will use density equals mass divided by volume, and our solve is going to show us simply plugging in the values for mass and for volume. You'll do a calculation 94.5 divided by 35, and notice that the units in this case do not cancel out because grams and centimeters cubed are different, so the unit ends up being grams divided by centimeters cubed. All right, so here's another practice problem. You can pause on these if you would like to, try to work it out yourself perhaps, and then unpause for a solution. All right, so here's the solution. All right, and then I'm not going to dwell on these because the next few problems are all solving for density. So if you want more practice, again, pause, work it out yourself, then look for the solution. Oh, I'll stay here for a second. There you go. All right, number 4, there's the problem. And here's the solution. All right, and here's number 5. That's the problem. And here's the solution. All right, now number 6, I'm going to talk about this one because it's a little different. All right, so we have a solid cube of impure zinc metal, 3.5 centimeters on a side, has a density of 6.95 grams per centimeter cube. What is the mass of the cube? So there's actually several things going on here. One that you might notice is, hey, they don't give us the volume directly. They do give us a way to figure it out because they tell us it's a cube and they tell us how long a side is. So maybe you remember with a cube, the length, the width, and the height are all the same. So you would basically just do length times width times height, or 3.50 times 3.50 times 3.50 to get the volume. And then they're asking us to solve for the mass, which is something we haven't done yet. So let's work through this and see what we can do. Now, what is the unknown? The unknown is the mass of the zinc. That's what they asked us to solve for. The knowns are all these things that they told us that are useful in the problem. Sometimes I'll give you extra information. So most of the time you'll use what's there, but sometimes you may have something that's left over that you don't need. But anyways, the density is given and the length of each side. So our plan, so first we're going to have to use the volume, or get the volume using length times width times height, knowing that a cube has all the same side like we talked about earlier. So, and then we'll use that in the density equation to solve for the mass. All right, so first off, we calculate the volume. It's 42.88 after we multiply out the all three sides. Or maybe I should say all three dimensions. All right, now the density equation, and follow this, so density equals mass divided by volume. Notice you don't have to do it this way, but sometimes this helps with seeing how the units work out. So the density was given in grams per centimeter cube, so that means centimeters cubed is actually in the denominator. So you can express the density as a fraction where the number of grams is in the top and the centimeters cubed or milliliters is in the denominator. And then that sets up a situation where, like, well, what do I need to do to solve for this? So in order to isolate M, the mass, which is what we want to solve for, So we can cross multiply, and that would give us where we have essentially the unit that we want, except, or excuse me, the variable that we want isolated, except we would need to move the centimeters cubed back over to the other side. So just divide both sides by centimeters cubed. Notice that centimeters cubed here and centimeters cubed here cancels out, and leaves us with the unit of grams. So 6.95 times 42.88, that gives you 298 grams. It's actually a pretty heavy cube because 3.5 centimeters, you could hold that in your hand, certainly. All right. So, density practice problem number 7. This is the one that I've found students have the most difficulty with. So, it's all about algebra. Most of you will set it up just fine. So we have an irregularly shaped piece of gold with a density of 19.3 grams per centimeter cubed. It has a mass of 428.4 grams. Ask what is the volume of this piece of gold. So the unknown is volume, the knowns, the density, and the mass. And, well, the plan, use the equation that relates all three of those things to each other, which is density equals mass over volume. And then we'll plug in all of the values, and again we put the per milliliters in as something on the denominator. And then we need to isolate the volume. And the most common error I see students make is simply take 19.3 and divide it by 428. And that gives the wrong answer, because what you have solved for is V in the denominator. You need to solve for V in the numerator to get a correct answer. So what do I mean by that? Well, we want to solve for V, and if we do the cross multiplying thing, we would do 19.3 times V equals the milliliters times 428.4. And when we do that, you'll see that you still haven't isolated the V yet. So to isolate the V, divide both sides by 19.3 grams. Notice the grams will cancel out over here now. And that will leave us with a unit of milliliters, which is good because we want to find milliliters. Now, you might be like, Mr. Renner, it says centimeters cubed. Well, yeah, centimeters cubed and milliliters are the same. So that is actually a true statement. Now, if you wrote milliliters for the answer, that would be fine with me. This is another thing that you may not have noticed about gold previously, because you probably haven't handled large quantities of it, but it's very heavy for its size. 22 centimeters cubed or 22 milliliters is maybe what you would think of as a single swallow or drink of water. So, you know, again, a piece of gold that would fit in your hand would be pretty heavy, 428 grams. So that would be about a pound for a pretty small quantity. Now, with that worked out here, please do make sure that you are paying attention to units as you work these problems out, where the units cancel out, and also make sure that you are moving these variables especially when you solve for volume, make sure that you follow this process, cross multiply, so that you're able to get the variable isolated that you want to solve for. All right, thanks for watching.